Welcome to The Explainer. Today, we're talking about something straight out of science fiction, turning your thoughts directly into actions. We're going to dive deep into the technology that builds a literal bridge between the human brain and a machine.
All right, so here's our game plan. First, we'll get into why this tech is so crucial. Then, we'll look at the device making it all happen, and we'll break down, how it actually translates a neuron's whisper into a real command. After that, we'll see the life-changing results. And finally, we'll peek into a future that, well, it's pretty wild.
Okay, so first things first. To really get this, you have to understand two huge problems that set the stage for this entire breakthrough. One is scientific, and the other is, well, it's deeply, deeply human.
Just imagine this for a second. What if your mind was perfectly sharp? You could think, you could feel, but you couldn't command your body to do anything. That is the heartbreaking reality for people with conditions like high spinal cord injuries or ALS. Their mind is alive, firing off thoughts and commands, but the connection, that highway to the body, is just broken. Those signals are trapped.
Meanwhile, on the scientific side of things, neuroscientists are grappling with a totally different but kind of related problem. They have too much information. The best analogy is this. Imagine trying to follow one conversation by listening to every single person in a giant stadium talking at once. That's what they call the curse of high-dimensional data. You can record all the noise, but trying to find the actual, meaningful signals in that chaos, it's a monumental challenge.
So you've got these two massive problems, right? A human mind that's locked in, unable to talk to the body, and scientists who are drowning in data, struggling to decode the brain's language. The solution to both? Well, it's a piece of tech that can act as a real-time interpreter for our thoughts.
And that technology has a name. It's called a brain-computer interface, or BCI for short. Think of it exactly like that. It's a direct bridge built right over that broken connection between mind and body. It's designed to translate the language of our neurons into the language of computers.
Now, one of the biggest names pushing to make this a reality, and you've probably heard of them, is Neuralink. Since 2016, their entire mission has been about giving independence back to people with paralysis. And this isn't just theory anymore. They've already taken that huge leap from the lab into FDA-approved human trials.
Okay, so how on earth does this actually work? Let's trace the journey of a single thought, right from a tiny neuron firing in the brain all the way to becoming a click on a computer screen. It's incredible.
And here's the thing. This whole process happens faster than you can blink. It all kicks off with a thought, right? Just the intention to move something. Instantly, more than 1,000 microscopic electrodes pick up those little electrical whispers from your neurons. The implant itself digitizes that raw data and just beams it wirelessly to a computer. And that's where the magic happens. Smart algorithms analyze everything, decoding not just the signal but the intent behind it. And just like that, your thought becomes a command.
And this is what makes this tech such a massive leap forward compared to something like, say, an EEG. An EEG is non-invasive, you just put it on the scalp. But the signal you get is, well, it's muffled. It's the sum of millions of neurons, all filtered through your skull and skin. A BCI, by being invasive, gets a crystal clear, high-def signal right from the source. It really is the difference between listening to a concert from the parking lot versus having a front row seat.
And this is so important to remember. This is not science fiction anymore. For the very first people in these trials, this technology is already changing their lives in ways that are just profound.
Yeah, the human side of this is really what it's all about. For people like RJ, a military vet living with paralysis, a BCI isn't just a gadget. It's a connection back to the world. It's a way to get back that sense of purpose.
So what does that restored connection actually look like in practice? Well, it looks like playing a game of chess. It looks like posting on social media or just surfing the web, all using just your mind. There's one case where a participant is using it for professional CAD software, holding down a full-time job. This isn't just about getting back hobbies, It's about getting back a life. But look, Neuralink isn't the only company in this race. The whole field is this fascinating balancing act, this trade-off between risk and reward. So on one end, you've got companies like Neuralink going right into the brain to get the absolute clearest signal possible. But on the other end, you have companies like Synchron, who are trying this really clever approach with a stentrode. They literally snake this sensor through your blood vessels to get to the brain, which means no open brain surgery. The trade-off? The signal isn't quite as detailed.
And it's this competition, this variety of approaches, that's really driving things forward. You've got Synchron, all in on safety with their blood vessel method. Then you have Paradromics, who are chasing what you might call the holy grail, restoring natural-sounding speech. And then there's precision neuroscience, working on this super thin, flexible film that just rests on the brain's surface and is even removable. Each one is betting on a different strategy to unlock the brain's potential.
But here's the crucial point. Restoring movement, that's just the start. That's step one. The real, long-term vision here is to use this technology to tackle a whole range of neurological disorders.
I mean, look at this roadmap for the future. It is absolutely breathtaking. In just the next few years, we could be looking at prosthetics that can actually feel things. A little further down the line, can you imagine a device that predicts and stops an epileptic seizure before it even happens, or one that intelligently treats the tremors of Parkinson's? And long-term, we're talking about the potential to help with memory loss, manage chronic pain. The list goes on and on.
Okay, but to get to that incredible future, we have to be realistic. The field has to climb some enormous mountains. There are huge technical challenges, right? Like making sure these implants and their signals can last for decades. Then there are the practical hurdles, things like cost, and who can even get this? And then, maybe the biggest mountain of all are the massive ethical questions we have to start answering, like right now.
And these aren't just little questions. They're some of the most profound questions our society has ever faced. Seriously, who owns the data that comes directly from your brain? How do we stop it from being hacked or misused? Where do we draw that incredibly fine line between therapy and human enhancement? These aren't just technical puzzles to solve. They hit at the very core of what it means to be human.
And that practical side of things is just as intimidating. When the initial cost for one of these procedures is estimated at over $100,000, you have to ask the hard question. How do we make sure this life-altering technology doesn't just become a perk for the rich? That's going to be a major test for us as a society.
So yes, the revolution is real. It's happening. But it is absolutely a marathon, not a sprint. The old Silicon Valley motto of move fast and break things, that just doesn't fly when you're working with the human brain. Every single step forward has to be built on this foundation of safety, of stability, and of deep ethical thought.
So at the end of the day, we've basically proven that we can build this incredible bridge between the mind and a machine. The tech is coming, but now the really hard work begins, deciding where that bridge is going to take us. The most important question isn't a technical one anymore, it's a human one. It's about who we want to be in an age where our very thoughts can be read.